So right, this is Elixir code is Elixir. I'm going to be using a lot of Elixir talking about Elixir, so sorry in advance. It's a metaprogramming talk. Today is February 2nd, like has been said. We're at EMPEX LA. I'm Adrian. I'm an engineer. I work at a startup in New York called Teachers Pay Teachers. We use Elixir. Sometimes I'm a speaker. I like to speak at things like this for things that I've learned, and now I'm here. Like I said, I work at Teachers Pay Teachers. We use Elixir pretty heavily on our backend for a bunch of our services. We also use React and TypeScript for a bunch of other things. So let's talk about Elixir. So Elixir, as per elixirlang.org. I'm sure that there's some folks that have not touched Elixir too much, so this will kind of like lead into how my talk goes. So it's a functional language. I'm sure some of you know that already. It's built on top of Erlang, and we get to utilize a lot of its fun, low latency distributed fault-tolerant systems of Erlang. So keep in mind that the Erlang VM is very important to Elixir as the language itself. So as for metaprogramming, a couple of folks have not really explored metaprogramming too much. So it's basically taking in some data from another program you've written. So this is from the wiki page for metaprogramming. It's pretty nice. So think about something like you do repetitively, and you want to make boilerplate for that. That would be a really nice use case for metaprogramming itself. So we've seen this screenshot, not this exact screenshot, but a very similar screenshot from Aaron's talk. Elixir is actually written in Elixir. We see that there's about 90% of the code base is written in Elixir, and like I said before, the biggest chunk after that is Erlang. You have the makefile, and then the rest is just how to build and compile Elixir. So you've got a bunch of scripts. So how does that work? Quick, short answers, def macro, and a more or less simple bootstrapping process. So bootstrapping Elixir, what does that look like? So there is an Erlang module called Elixir Bootstrap, and there's an Elixir module called kernel. So let's take a look at the head of Elixir Bootstrap, the Erlang module I just mentioned. This is not the entire file. I could actually probably fit it on this screen, but I refuse not to. But if you see in the top comments basically saying that it's an Erlang module, and it's going to behave like an Elixir module. And if you see in the export, outside of macro dash, you'll see the keywords that you expect in Elixir. So you've got def and its arities, def p and also its arities, and def macro itself. And we're defining this module as elixir.kernel. So I guess you want to think of Elixir Bootstrap exactly as its name implies. It's a way to bootstrap elixir.kernel. And to look at kernel.ex, this is also just in the head of kernel.ex. It uses Elixir Bootstrap and imports that to bootstrap another version of kernel. So kernel is the beginning of Elixir being written in Elixir. So to understand this a little bit more, let's build Elixir. Let's look at the makefile very briefly, because you could do a lot more with the makefile. I'm just going to explore most of the minimalist options. So a simplified view on how to compile Elixir. You're going to make Erlang. You're going to make Elixir app. And then you're going to make the standard lib. That'll get you up and running. So I put make Erlang and Elixir app together, because that's pretty simple on what it does. But what you want to notice is that we're making the Elixir Bootstrap Erlang module, and it compiles all of the other Erlang modules in libelixir source. So we are compiling all of the Erlang code first. So now let's take a look at make standard lib and how that works. So this part we are at the bootstrap process, but we've already got our Erlang modules already compiled, and we're now going to start using those to compile the Elixir code that we have. So here's kernel.ex, and it does the rest of the Elixir files that are in Elixir Lib. So just to kind of look into what Make Standard Lib does a little bit closer, one of the Erlang modules that we compiled was Elixir compiler, and it does this little thing, Elixir compiler and Bootstrap. If you look in that file, it lists out all of the other Elixir files to write. Basically takes all of your Elixir code, writes it down to Beam bytecode, and now it's available. So Elixir compiler, it's an Erlang module, compiles Elixir to Beam code. So recap on things so far. We're compiling Erlang code. We're going to get a minimalist version of kernel up and running. And then we are going to compile our Elixir code to get what's actually going to be the end-up kernel that you're going to see in what we have in Elixir. So let's take a look at some of the kernel code. Things that you would typically see. Like I said, Elixir is based off of Erlang, so things like this, so def div is really just a wrapper around Erlang div. It takes the same arities. We're passing the same exact signature into Erlang's function. Same thing for isBinary. We're just using Erlang's isBinary, same function signature, and it's just a convenience wrapper, so we could use it within Elixir. So now let's look at more of the fun things in kernel. If. So if is actually a def macro, takes in the condition and some clauses, which is a keyword list. So condition is something like 1 + 1 = 2. Clauses is do this, else do that. And buildIf is your helper function that you'll see to do said condition or clauses. So right, if is really just a macro. But what else is a macro? And def macro is actually a def macro, which I glazed my eyes over for a while trying to understand that. And I decided that was for another time because I wanted to use my time very wisely with my 20 minutes. I'll probably look into writing a blog post about that. So let's look back at how if is implemented. So here's the definition again for def macro. And here's buildIf, the helper function, which it does. So you can see in the second version of buildIf, that's where the bulk of the code is. So taking a look at that, we have something that's quote do. Another thing which is unquote. Optimize Boolean is a little helper function within kernel, which you can take a look at. It's not too much. The chunks that I want to talk about are what quote and quote unquote does. So right, let's take a look at what quote does. So for another example of just what 1 + 2 looks like, this is basically getting an AST of what 1 + 2 looks like in Elixir. So we have, within the context of Elixir, we're importing kernel, and we're doing the plus with the variables of 1 and 2. Right? So what about unquote? So let's say we bind 1, the word, to 1. And then we try and do quote do on 1, the word, plus 2. We now see that 1 is now an atom, and it's no longer the number 1. So what unquote does, if we quote do unquote 1, the word plus 2, now we get exactly what we had previously here, the AST with the actual parameters of 1 and 2. So I've ripped out some of buildIf just so for a little bit more clarity. What buildIf does, we're doing some quote to have case unquote the condition. So let's say we have 1 + 1 = 2. We're saying that within that case, if it is false or nil, do the else clause, and otherwise it is true. So a quick summary of if. If is a macro. So if is actually just a case, and we basically just check if it's nil or false. and otherwise we'll do the do clause. And you can actually just write if, like kernel.if, and then it'll take in that first parameter as a condition, and then you're doing something. Here I'm just passing in an atom as a return, and else no. So we've gotten to the point where we want to build our own macro. As a simple case, let's say we do a lot of dividing, but we also need the remainder for something. So that kind of looks like you want to do div 5 divided by 3, you get 1. Rem 5 divided by 3, you want to get 2. So let's now build our new macro. Let's just call it div rem. That's what a simple function signature would look like, or macro signature would look like. And we're going to do a quote do, and then we're going to unquote the dividend and divisor so we could use those variables. And let's say we just want to return a tuple. We'll just wrap our code and call Erlang's div and Erlang's rem with the same exact function signature as we would expect. And that's pretty much it. Sorry about the tabs here. They didn't align quite correctly, but here it is all together with more aligned. That's all we want to have done. So we've built our first macro. So now if we add that to kernel.ex, we can build our new Elixir. We'll make Erlang. We will make Elixir app. And we'll make Standard Lib. So now we can get a tuple with a div and rem. So here, after we've done all that, you could actually run this. We're having div rem run 5 divided by 3, and we'll also get the values of 1 and 2. Same thing for 2 and 1, same exact example, same exact type of data that I would expect. It looks pretty good. I'm happy with this. So we've come full circle. We learned about Elixir by making Elixir, by extending Elixir in Elixir. So some caveats and learnings. They say that rule number 1 about macros and metaprogramming is don't write macros. It's a very dangerous subject. I think I would say to tread lightly. There are a lot of fun things that you can do by extending a lot of your ecosystem within Elixir for making things easier for other engineers. But with that being said, boilerplate helps, yes, but ensure your engineers know when macros are being used. So a case example is that we use a bit of macros in our testing suite just to get a lot of our boilerplate on how we write our tests and which databases to write tests to. And we don't want to have our engineers coming in to constantly do that. It was a pattern that we saw, so we saw a need to write our own macros. With that story being said, when we spun up a new project in Elixir, an engineer kind of asked me, it's like, hey, this test isn't working exactly how I thought it was, but it definitely works the same way in our other library. And point being is that this person didn't realize that the macro did all that work for you. So if you're designing some sort of macro that does a lot of high-level things for you, make sure that you're all on board on you knowing what it does and how it's implemented. So DSLs are helpful, but can be dangerous. If you are writing any sort of DSL for any sort of library, I would say just be careful about the language and constructs. Things can overlap. It's like, so for example, for if, as a very good example, That is very common. I would expect that in a language. You could probably extend a lot of the language into other sort of verbs. Just be aware that writing sort of new DSLs for any sort of specific language can be dangerous as long as you're writing this amount of data and you're basically creating a new language. So read Metaprogramming Elixir by Chris McCord. It was very helpful in the way that we do a lot of our metaprogramming, a lot of do's and don'ts. There's a lot of fun things that I learned along the way. And thank you, EMPEX. I left a good 5 minutes because I wanted to take any sort of questions. I'm on Twitter and GitHub. I'm Adrian Cruz. I work for Teachers Pay Teachers. If you wanted to hear more about that, we are hiring. A lot of our code is in Elixir. We use GraphQL and Absinthe. And my slides are actually already online. Thank you.